This is the review for the Chapter 3 geometry test that is happening tomorrow. It says to identify the plane parallel to VUZ. We've been having a lot of difficulties with this concept. VUZ goes from point B through U and Z, and it includes Y as well in that plane. So I'm going to highlight the plane. If I can get my pen to work. This is the front of this box. Okay, the plane parallel to it would be a plane that doesn't touch it. And the only one that wouldn't intersect with it would be the back of the box. So the answer to this one is plane STW, or just use 3 letters to name it. I'll just say plane STW. It could be STX, it could be SXW, any 3 letters that are on that plane. Just to identify second, the intersection of planes STB. Now this is where the planes intersect. So STB I've already got highlighted in the back. I think I'll color that in a little bit. Okay, so that's the back of the box. Next I want to see where plane TWY intersects it. So that would include the points T, W, and Y. And actually there's a hint right there. Where did those overlap? Was on that edge right here. So that would be the line TW. 2 planes always intersect in a line. And you can reverse those letters as well. But that is the only answer to that question. The intersection of the back and the right side planes is the line TW. Identify a segment parallel to XZ. So I find segment XZ. I need to find a segment that runs in the same direction as XZ, so it would be parallel. An example would be segment VS. Another example, segment UT, or WY, or YW. It doesn't, again, matter. When you name a segment, these are or. You can have one or the other of the 3. Name a segment skew. The concept of skewness is non-parallel lines that do not intersect. Okay, so if you're talking about TW right here, and you want a line that would never run into it, but is not parallel to it, meaning it can't be SX, UY, or VZ, something such as VS would work because it's going to keep going and never run into that. So segment VS, or another segment that would never run into TW would be VU. Another segment would never run into that red segment back there would be ZY. Or, let's see, ZX. Never is going to hit it either. Now, again, it has to not be in the same plane, so it can't go in the same direction if it's skewed to it. So, although UY will not run into TW, it is not skew because it's going in the same direction. It's actually a parallel segment. So these are skew segments to segment TW. A plane parallel to plane TWU would be, this is the right side, so it would be the plane on the left. So you just need 3 letters, plane VSX. Or any 3 letters within those 4. You could have Z in there. The intersection of plane VSX, which I have highlighted over here on the left side, and plane XYZ, X, where's the X? X, Y, and Z. It's going to be the bottom. Okay. So where that left side and the bottom intersect is in line ZX, or XZ. Next, the name is segment skew to segment ZY. Okay, I'm just erasing quite so I can show. ZY is right there. If I want a segment skew to it that doesn't run into it, SX would be an example, or TW. Can't use XW because it's parallel to it. Can't use ST because it would be parallel. But then I can go this way. VS would be another example, or UT. and a segment parallel to VZ. VZ is going straight up and down. The other sides that do that in the diagram would be UY, for example, or TW, or SX. Those are parallel to VZ. Identify a special name for each angle pair. It doesn't indicate that A and B are parallel, and that doesn't matter when you're just naming a relationship between them. If you're talking about angle 4 and angle 8, those would be corresponding angles. And corresponding angles are the kind of angles that are in the same spot along the transversals. That's one way to put it. Or it could be, you could say, in same position. Okay, they're on the same side of the transversal in the same position along the lines that are cut by the transversal. So any description of that I'll probably be fairly good with, as long as it's not completely off the wall. Angles 2 and 7 would be called alternate on the alternate exterior angles, and they are on opposite sides of the transversal on the outside. Okay, outside of lines cut by the transversal. I might have worded this differently in the key. I'm just trying to say it any way I would be acceptable. Angle 3 and 6 are alternate interior angles, and that's because they are on opposite sides of the transversal on the inside of the two lines, A and B. Inside, oops, not inside, inside of lines. Angles 1 and 4 are vertical angles. And those are angles across from each other, is one way to put it. Okay, those are the kind of words we use together in class. Oh, 13. Given A is parallel to B. So now we're told that A and B are parallel. Find the measure of angle 4 if the measure of angle 5 is 115. Well, 5 and 4 are, I'll highlight these, made by a kind of a S, if you will, backwards. They are congruent because they're alternate interiors, so angle 4 is 115. Given A parallel to B, and angle 1 is 5x plus 10, and angle 8 is 3x plus 50 by the alternate exterior angles theorem, well, which says alternate exterior angles are congruent if the lines are parallel. We would set these equal, and then we would solve algebraically, subtracting 3x from both sides. We'd have 2x plus 10 is equal to 50. I'd subtract 10 from both sides, I get 2x is 40, divide by 2, and x is 20. We've been solving algebraic equations all the time since the beginning of school. Each angle relationship justify A being parallel to B. Well, angle 1 and 7 being congruent would be a big no. Those are not in any relationship. That's just yes or no. Angle 3 congruent to angle 6 would be yes. Because if alternate interior angles are congruent, then the lines are parallel. So alternate, and this would be the reason, alternate interior angles congruent implies parallel lines. Angle 3 congruent to 7 would be yes, because if corresponding angles are congruent, then you have some parallel lines. 4 and 1, no. Doesn't make any lines be parallel. They're just congruent because they're vertical. And angle 6 and 8, no. They wouldn't be congruent in the first place unless they were both 90 because they form a linear pair. And 7 and 2, 7 and 2 would be a yes. And that's because if alternate exterior angles are congruent, then you have some parallel lines. 16, which postular theorem would justify A being parallel to B? If you're given that angle 4 and 5 are congruent, the postular theorem would say that it would be if alternate interior angles are congruent, then you have parallel lines. Now, I know some of the teachers are saying the converse of the alternate interior angles theorem. Alternate interior angles theorem converse. I prefer saying what it says. So I would prefer to see alternate interior angles congruent than parallel, and that is what we put in our ISN. For measure of angle 6 plus the measure of angle 40 and 180, it justifies that the lines must be parallel because if consecutive interior angles are supplementary, then you have parallel lines. That is the converse of the consecutive interior angles theorem. So some teachers would accept this. I prefer this. Consecutive interior, converse of consecutive interior angles theorem. And I think a lot of them may make you write converse at the end. Okay, so now 3 and 5 are going to be supplementary. 6x plus 10 plus 4x plus 60 is equal to 180. And because if these lines are to be parallel, those consecutive interiors need to be supplementary. First step to solving is to combine your like terms on the left side and then subtract 70 from both sides. Divide by 10 and we get 11 for x. 19, finding the slope, x1, y1, x2, y2. The formula is y2 minus y1. You got to do the y's first over x2 minus x1. So I'm going to do 2 minus negative 8 over 1 minus negative 4. 2 minus negative 8 is 2 plus 8. 1 minus negative 4 is 1 plus 4. That gives us 10 over 5, and that reduces to 2. Oops. Using x1, y1 on the next set of points. x2, y2. Negative 12 minus 0 over 1 minus 4 gives me negative 12 over negative 3, and that is 4 for my slope. Write an equation in slope-intercept form of the line with the slope of, that's an m value, and a y-intercept, which is a b value. We use the equation y equals m times x plus b, and we just substitute in m of negative 4 and a y-intercept of 1/2 plus 1/2, and that is the end. Write an equation in slope-intercept form of the line with a slope of 1/2 and a y-intercept of 12. Or 1/4, excuse me. Y equals 1/4 times your x value plus 12. Write an equation of a line with a slope of 3 passing through the point x1, y1 would be 2, 1 in point slope form. It said to put it in point slope form, which means we get to leave it in the form y minus y1 equals m times x minus x1. We put in the m value of 3. We put in an x1 value of 2, a y1 value of 1. That's it. It is simplified. You don't have anything else to do except leave it in that point slope formula. Write an equation in slope-intercept form for the line that satisfies the conditions. All right, now we have a little more work to do. We start off using the point slope formula, which we're going to have x1 is 4, y1 is 5, and m is negative 1/2. So I've substituted in the values in the correct positions. the next step, I need to distribute the negative 1/2. Negative 1/2 times x, negative 1/2 times a negative 4 be a positive 2. And then the last step on here is to add 5 to both sides. And now it will be in slope-intercept form, which is y equals m times x plus b form. It'll say y equals negative 1/2 x plus 7. The next one has 2 points given, so we have a separate step than we did on the last one. First, we must find the slope using y2 minus y1 over x2 minus x1. That's your m value. So that's going to give us 11 minus 6 over negative 3 minus 2. That's 5 over negative 5, which is negative 1. I will choose the first point and substitute it in to the y minus y1 point slope formula. And that would give me y minus 6 equals, and I put in a negative 1 for my m, x minus 2. I distribute the negative 1 over the x and the 2, giving me negative x plus 2. And then I would add 6 to both sides. And my final answer for this one, y equals negative 1x. You can write the 1 if you want, plus 8. I think I went very quickly here, so I'll double. 6 is 5, yes, negative 3, good. I put in 2 and 6, yep. Okay, adding, that's it. (26) Write an equation in slope-intercept form, the line that satisfies the given conditions. Through the point, x1, y1, negative 8, 7, parallel to a line with this equation. This equation gives a slope of negative 5. It is in y equals m times x plus b form. So I was looking right here at the slope number. Slopes do not include an x. They are just located attached to the x. They are called the coefficient of x. That negative 5 tells me the slope of this line is negative 5, which means the line parallel would have the same slope. So that means its m is going to be negative 5 also. Now that I have that point, I'll use my my point slope formula, which is, as I've stated over and over already, y minus y1 equals m times x minus x1. I'm going to pop in these values, y minus 7. I got a slope of negative 5. I got an x value of negative 8. And I need to do some work on this. Negative 5x. I cannot leave this minus negative 8. I have to write x plus 8. We would never leave it like that. And then it did say to put it in slope-intercept form, which is y equals m times x plus b. So that means I need to continue by distributing the negative 5 over the x and the 8. And then final step, I'll add 7 to both sides. And my final answer is y equals negative 5 times x minus 33. Next one, I have y minus 7 equals, okay, and so I put in m of negative 4, x minus 1. I would need to then distribute the negative 4, y minus 7, this is again my x1, y1. Negative 4 times x, negative 4 times negative 1 would be positive 4. And then I would add 7 to both sides to get my y alone. And I have y equals negative 4 times x plus 11. A plumber charges Yolanda $100 to come to her house to assess a problem. A lot of companies do. They charge quite a bit of money to show up. Then she charges $65 an hour to fix the issue. Write an equation for the cost C of having the plumber come work for 8 hours. So every hour that person is going to get $65. So she's getting 65 times every hour. But not only that, she has charged you $100 to show up. I wish I had that. That's going to make some pretty good money. If she needs 4 hours to finish that work, we're going to have a pretty big bill. We plug in 4, we get see, what's that? 240 plus what? 260 bucks just for the time. So it's going to cost us $360 for her to do that work. Plumbing is expensive. Now I got some printer's ink, so that price isn't going to be as bad. We got to pay $1.12 a page, so that'd be $1.12 times P, the number of pages. And plus, you got to pay $7 to bind it. There we go. What would it cost for an 80-page report? $1.12 times 80. That's kind of expensive per. They must be color. Oh gosh. I think I'll grab the old calculator for that one, because I know you guys would. $1.12 times 80. 88. Don't need that. Okay. So I get out of there. We were graphing some problems the other day in my honors class. 112 times 80. At least I'm going to find out what that is, since I forgot now what was on my paper. 89.60. That's what I thought. All right, so 89.60 plus $7. I'm going to have $96.60 to pay for that 80-page report. Okay, determine whether line CS and KP are parallel, perpendicular, or neither. Line CS has a slope of 1/4, and line KP has a slope of -4. Two ways to look at this. 1/4 and -4 are opposite signs, or negative reciprocals. They are also flipovers of one another. They are negative reciprocals. Therefore, the lines would be perpendicular. And another way to look at it is 1/4 times -4 is -1. That's another way to tell. Well, 1/5 times 1/5, that doesn't do a darn thing, but give you -1/25. So these are neither parallel nor perpendicular. They have to be identical for the lines to be parallel. These are simply opposites, and that does not make lines perpendicular. Some people had that misconception on the last quiz. You have to have them be both opposite in sign, one positive, one negative, and reciprocals, as I like to call them. 2/3 and 6/9. Well, if you take 6/9 and say, reduce that, please, divide by 3, top and bottom, and reduce it, it's 2/3. So these are equal slopes, therefore they are parallel lines that would pass through those lines with slope that are the same. Given line AB has a slope of 7, write an equation of a line perpendicular to line AB. Okay, well, we can have a lot of varying answers. The format I'm going to use is y equals mx plus b. You can have bb 0, you can have bb any number you want. The problem is, if you want it to be perpendicular to a line with a slope of 7, it has to be the negative reciprocal of 7, which would be -1/7. So any equation you write with a -1/7 slope would be an accurate answer. You can have anything you want right there. Line AB has a slope of -1/5. Write an equation of a line parallel. It can be any answer you have with a -1/5. X has to have identical slope plus any number you want to put in the question mark position. Could be a 0, could be anything. All the lines perpendicular to the line y equals 5x plus 5 would have, if they are perpendicular to it, their slope should be negative and 1/5, or an equivalent of -1/5. The trickiest one right here is looking at this, -0.2. -0.2 is -2/10, which equals -1/5. So this is actually a line perpendicular. 0.2, that's 2/10, which is 1/5. Nope. Y equals 8, that's a horizontal line. No. If I solve this one for y, I'd have to subtract 1/5 from both sides, 1/5 x. And now it does have a slope of -1/5. This one's a yes. This one has a slope of -1/5, so that's a yes. And this one has a slope of 5. Oh my goodness. Yes, it would have, it's exactly the same slope, therefore it would have been parallel, not perpendicular. Okay. Calculate the slope of the line through 3, -1, and 5, 4. 4 minus -1 over 3 minus 5. That would be, what I just did was, this is x1, y1, this is my x2, y2. Subtract your y's first, y minus -1. Subtract your x's, 5 minus, I should have done 5 minus 3. So I made a boo-boo just now because I went too fast. All right, since I started with y2, 4 minus -1, I got to go back to this one and do 5 minus 3. 4 minus -1 would be 4 plus 1, and that's 5 over 2. So the slope is 5/2. The slope of the line parallel would be 5/2, and the slope of the line perpendicular would be, flip it over, change the sign, -5/2. Given P parallel to H and BP parallel to Q, state the postular theorem that justifies each conclusion. All right, first of all, if I got G parallel to H, let me highlight those two. And I'll go with P and Q parallel. Oops, I didn't do a very good job, but well. What postular theorem justifies angle 2 being congruent to angle 5? Those are along the lines P and Q. That would be if parallel lines. So parallel implies those are corresponding angles that are congruent. That's the corresponding angles postulate. 5 and 7, now I'm talking about lines G and H. It didn't say which ones to mention that. So these are alternate interior to angles G and H. So parallel implies alternate interior angles congruent. 2 and 6 being supplementary. If you have parallel lines and consecutive interior, parallel implies consecutive interior angles supplementary. And 4 and 9 being congruent, alternate exterior angles. Parallel implies alternate exterior angles are congruent. And finally, given G parallel to H, the measure of angle 8 is 80. Find the measure of angle 5. It would be 100 because those two are supplementary. Consecutive interior supplementary. Identify each pair, alternate interior, alternate exterior, etc. Okay, also name the transversal, angles 2 and 6. Those are alternate on the interior, alternate interior angles, and the transversal is line A. Course C, 14 and 15. Those are consecutive supplementary, consecutive interior, and the transversal is line B. That's because it's the line that cuts through and makes those angles between L and M. That's why these are interior on the same side. 13 and 12. Okay, now we're looking here at line B being the transversal again, and alternate. They are alternate exterior angles. So they're outside of the two lines L and M along the transversal B. Okay. Identify again and also name the transversal if asked. 7 and 8. Those are a linear pair. They make a straight line. 12 and 15 are vertical angles, no transversal. Given line M and L parallel, the measure of angle 8, 86. Find the measure of angle 6, 86, because they're corresponding. And given that L is parallel to M and M, angle 7 is 6x minus 5. Angle 6 is 4x plus 25. Those are supplementary. So 6x minus 5 plus 4x plus 25 equals 180. That's 10x, oops, 10x for adding the like terms, and then negative 5 and 25, we have plus 20 equals 180. Subtract 20 from both sides. We got 10 times x is 160. Divide by 10 and we get x to 16. Okay. If angle 10 is 108, let's see, now that would have to do with L and M are the parallel lines, guys, so we want to be sure that we know what angles are like hanging out with each other or actually have a relationship. L and M are the parallel lines. So up here, when A is the transversal, those are in a relationship versus the ones down here. That's a separate relationship. So what I'm saying to you is, if I've got angle 10 is 108, I'll write that very clearly there. The only angles that are related to it are the ones down here. Okay, where I have circled in green. This would be 72, this would be 72, this would be 108. Now, I know these aren't looking like that's the correct size of them, but the measure of angle 1 has nothing to do with those. So I need to look at this part that he gave me here that says the measure of angle 6 is 52. That's going to have something to do with angle 1. So what I do is 180, oopsie, minus 52. And I find out that's 128. So that means this angle is 128. And angle 1 is 128. And it didn't say for me to list any reasons. I'm just giving some measurements. So I got 128 for angle 1. Angle 6 and 2 are alternate interiors, which are congruent. So it'd be 52. Angle 14, now that's got to do with the ones down here. So it's going to have to do with that 108 angle. It's going to be 72. Because it's a linear pair with the angle 10 and vertical with angle 9. Then I got angle 4, and I'm back up here with these numbers again. Okay, so I got to be careful what numbers I'm using. This is going to be 52. Okay, and 16, I'm back down here. So that's going to be 72. And then angle 7 is going to be 128. Because it's vertical to angle 1. Or supplementary to angle 2. Okay, got another set here. Hope I'm getting close to being done. It's getting really late, 5:45. Still recording. Angle 9, I've got 68 degrees. See, I've got angle 7, 117. Now I got to pay attention. What lines are actually parallel? So I don't make any boo-boos. It's M and N. Okay, so like I was discussing on the last set of problems, these guys are related, and these guys are related. Separately, differently. Okay, so angle 1 is going to be 68. It's corresponding to angle 9. Now angle 13 is going to be 117. It's alternate interior to angle 7. Angle 10 is going to be the supplement to 68. So it's going to be 100 and, is that 12? Let's see, 7, 8, yeah, 112. And angle 8, oh, it's related to the 117. So I'm jumping around again. These are supplementary, so I do 180 minus 117. That's going to be, let's see, what's that? 63. Oh, I'm getting so tired. And 16 is going to correspond to that, so it's going to be 63. And angle 11 is supplementary with the 112 or vertical with angle 9, so it better be 68. And it is. Measure of angle EBD is find the measure of angle EBD. Okay, I want to know that. If CBD, that's this whole angle, is 4x plus 14 from there to there. And EBD is 3x minus 9. Okay, well, these two angles add up to a straight angle line. So it's 4x plus 14 plus 3x minus 9 equals 180. 7x, and I got plus 5 equal, I simplified. Now I would subtract 5 from both sides. I get 7 times x is 175. Okay, so that's 25? Yeah, 25. There are 7 25s and 175. Now it did say to find EBD, so we're not done. To measure of angle EBD, we got to plug back in. 3 times 25 minus 9 is 75 minus 9, so it's going to be 66. 66 degrees. And finally, proof. I think we're getting there. A parallel to B has been given. We went over something just like this today almost in our review. Oh, not just that. We had it somewhere else. I don't know. We're going to prove J parallel to K. So do not do anything with J and K yet. A and B being parallel has been given. So angle 5 and 8 are congruent was given also. And then angle 2 congruent to angle 8. That's because we've got A and B parallel. So parallel implies corresponding angles 2 and 8 would be congruent. Or the corresponding angles postulate. 5 and 2 are congruent because we use these two steps to make this step. 5 and 8 congruent, 2 and 8 congruent, therefore 5 and 2 are congruent by substitution or the transitive property. I said I would take either one. And then J is parallel to K because we now have alternate interior angles that are congruent. So if alternate interior angles are congruent, then that means you got some parallel lines. Graph each line, go to 2, -1. Use a slope of -1/3, which would mean down 1 and right 3. So from that point at 2, -1, down 1, right 1, 2, 3, then we stop and we're like, well, I need 3 points. You said to graph at least 3 points. So I go to reverse that slope. The opposite of down would be up 1, and the opposite of right would be left 1, 2, 3. And see, they're lining up. You could do it again. Up 1, left 1, 2, 3. Now we can make a nice line through our points. Put arrows on the end. Another line at -3, 1 is our starting spot with a slope of 4. A slope of 4 would mean up 4 and right 1. So I go up 1, 2, 3, 4, right 1. I can't do that again, so I can reverse it. So I can go down 1, 2, 3, 4, left 1, and they're lined up. Make a line. Oops, that wasn't very good. Bam. Kind of got it. 65, this one's in slope-intercept form. Y equals m times x plus b form. And b is the starting place. All right, so I start there on the y-axis because it's called the y-intercept. So I start at -1. My slope is 2/3, means up 2 and right 3. So from there, go up 2, right 1, 2, 3. And I can't do it again, so I'll do it reverse. Down 2, left 1, 2, 3. And we practice this in class. Obviously, this is review. This line has a b value of 0. You don't see it, it's a 0. It starts at 0, 0 there. The slope of -2, writing as a fraction, means to go down 2 and right 1. So we go down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1. And we make a line. Okay. 67, graph the lines on the coordinate plane to the right and determine if they're parallel, perpendicular, or neither. The first line, I'm going to start at 1 on the y-axis. The slope of -1/3 means down 1, right 3, or up 1, left 3. So there's the first line. Oops, All right, now I'm going to write that better. Oops, it's hard on this slate. There we go. All right, that's the line A. Then it says graph y equals 3x. That has a y-intercept of 0, okay, and a slope of 3 over 1, which means up 3, right 1, or down 3 and left 1. Now, notice that these slopes, negative 1/3 and positive 3 over 1, the lines are perpendicular. They're running into each other at a right angle. And that's because they are slopes. The slopes are negative reciprocals. Or if you said opposite signs and reciprocals, that would be fine. Or if you said they multiply to equal negative 1 and show it, like negative 1/3 times 3 equals negative 1, that's another reason they're perpendicular. The slopes are negative reciprocals. Okay, and then you see we did have all the answers, and exactly those answers are what we just went over. So, time out. I hope you study. Hope you do well on your Chapter 3 test mañana, or whenever you decide to watch this. Have a great evening.